Good evening. This is Shashank, and
I'm Nitish Kumar.
we are going to do a video lecture on IEEE488 bus. So, the topics we will discuss today are the introduction, an overview or a tutorial view of the IEEE488 bus, how it operates, and the IEEE488 bus is also called GPIB, General Purpose Interface Bus, and how successful and a trouble-free operation it causes these days. So, Nitish Kumar now will discuss a brief introduction on the origin.
In late 1960s, Hewlett Packard manufactured various automated test and measurement instruments such as digital multimeter, logic analyzer. They developed the HP interface bus to enable easier interconnection between instruments and controllers. The bus was relatively easy to implement using the technology at the time. Using simple parallel bus, several individual control lines, HP licensed the HPIB patents for a normal fee to other manufacturers. It became known as General Purpose Interface Bus and became a de facto standard for automated and industrial instrument control. As GPIB became popular, it was formalized by various standard organizations.
Now, we shall look at another brief introduction on why it is a standard, why it is used as a standard. The GPIB is more like an interface standard. It is versatile till date. So, it's widely used and it's used for enabling electronics test equipments and to be controlled remotely, even a general computations. We can also look at this as it's widely used for enabling electronics. So it is used as a standard and it is compared with other types of bus. So and how it is compared and fitted often in many instruments, so which provides us a basic standard. Now, Nitish will go over the standards.
In 1975, the IEEE standardized the bus as standard digital interface for programmable instrumentation, IEEE488. It was revised in 1978. The standard was revised in 1987 and redesignated as IEEE 488.1. This standard formalized the mechanical, electrical, and basic protocol parameter of GPIB but said nothing about the format of commands or data. In 1987, IEEE introduced standard codes, formats, protocols, and common commands, IEEE 488.2. It was revised in 1992. IEEE 488.2 provided for basic syntax and format conversion, as well as device-independent commands, data structure, error protocols, and the like. IEEE 488.2 built on IEEE 488.1 without substituting it. Equipment can conform to IEEE 488.1 without following IEEE 488.2.
So now I'll go over the basic concepts, why it is a very flexible system and allowing data. So let's look at why the IEEE 488 bus is a very flexible system. So now the basic concept is GPIB. It stands for General Purpose Interface Bus. It used to be called as HPIB because HP found it. So Hewlett Packard Interface Bus. And then it's a very flexible system. It allows data to flow between any of the instruments on the bus at a speed suitable for the slowest active instrument. So if there are a range of speeds and there will be active instruments connected to a bus, and so the slowest active instrument will be the speed of the GPIB, the process, even though there might be active instruments which are way faster than the present instrument. And there are up to 15 instruments that can be connected to a bus within a span of 20 meters. and the length may not exceed 20 meters, or it's not exactly 20 meters, but it is something close to 20 meters. There, there must also be a distance no more than 2 meters between the adjacent instruments on the bus. It is possible to purchase a GPIB, a general purpose interface bus, to incorporate into computers that don't have the interface fitted as GPI. So as these are relatively cheap, these are used as a fitting standard, and these are all fitted to the back of any active instrument, and they are used as a mode, as a standard mode. So they and GPIB cards, they are relatively cheap nowadays. So this makes the inclusion of a GPIB card into any system a very cost-effective method. So you get a standard which is of a very low cost, and you're able to see whether your equipment works fine or not using a very cheap standard, which happens to be highly effective in this case. And the point I'll be covering is it's also easy to install it, and not just as a GPIB card for a standard. It's also easy to install it as a pin in the back of on the back of any active instrument. It looks like it's a diagram like this, which has two holes on the side and a set of 24 pins in the middle. So Nitish will now go over the characteristics of IEEE488.
IEEE488 is an 8-bit electrical parallel bus. The bus employs 16 signal lines. The 8 used for bi-directional data transfer, 3 for handshake, and 5 for bus management, plus 8 around return lines. Every device on the bus has unique 5-bit primary address in the range from 0 to 30. The standard allows up to 15 devices to share a single physical bus of up to 20 meters total cable length. The physical topology can be linear or star. Active extenders allow longer bus with up to 31 devices theoretically possible on logical bus. Control and data function are logically separated. A controller can address one device as a talker and one or more devices as listeners without having to participate in the data transfer. It is possible for multiple controllers to share the same bus, but only one can be the controller in charge at a time.
So now I'll be going over why the IEEE bus falls into 3 different categories and what those 3 categories. The IEEE bus is an equipment that falls into categories and fulfills more than one function. So as it fulfills more than one function, it obviously fits into more than one category. And the categories namely being a controller, a listener, a talker. Like he mentioned, this standard allows up to 15 devices to share, or like I mentioned previously, the standard allows up to 15 devices to share a single physical bus up to 20 meters cable length. But like he said, it's used for bidirectional data transfer and 3 for handshake. So whatever he has mentioned has already been listed out in mine. And when he mentioned talker, it obviously falls under my category: talker, listener, and controller. So those are the 3 functions which would come under this category.
And connectors. IEEE488 specifies as 24-pin phenol design micro ribbon connector. Micro ribbon connectors have a D-shaped metal shell but are larger than D sub-miniature connectors. One unusual feature of IEEE488 connector is they commonly use as double-headed design with male on one side and female on the other. This always stacking connectors for easy daisy chaining fever. Although a workaround involving physically supporting the connectors may be able to get around this. IEEE 6025 standard prescribes the use of 25-pin D sub-miniature connectors. This counter renowned gained significant market acceptance against the established 24-pin connector.
So now I'll be going over the advantages and disadvantages, and we'll wrap it up with that. So I'll just go over the advantages and disadvantages of the 488 bus. So the advantages are it's pretty simple. It's a pretty simple device and it's a standard for hardware interface. Yes, it is a standard for hardware interface. And the interface present on many, which as a many bunch of instruments. So it's like I said, it's as a standard, and you get that standard for a very cheap cost. So you get that installed for data transfer, and even if you have a highly sophisticated item, something better than this, you can also use this as one of your standards to test it. And it's possible to connect multiple instruments using a single controller. Like he mentioned, the controller, the one who takes control of the whole thing. So like that, this is possible to connect multiple instruments to a single controller. That proves the point. And now Nitish will go over the use as a computer interface, and then I will come back to disadvantages of the IEEE 488 bus.
HP's designer did not specifically plan for IEEE488 to be peripheral interface for general purpose computer. The focus was on instrumentation. But when HP's earlier microcomputers needed an interface for peripherals, HP IP was readily available and easily adapted to the purpose.
Now I should go over the disadvantages. It's a bulky connector, so the size, like I said, it's a huge pin connector, and it has two screws at the end which you have to fit it in, and so it's a bulky connector, and the cable reliability is poor, often as a result of being a bulky connector. Because the size is big, so the cable reliability is poor, and the bandwidth is low. The frequency it allows to pass through the data to pass through, it's a pretty low bandwidth. So compared to more modern interfaces, this is actually pretty slow, but still effective. We went over that and advantages. Now we're talking about disadvantages. The basic IEEE does not exist, but on a mandate command language like SCPI, it's used in later implementations, but not included in all instruments. So exactly, this is a disadvantage. It may be like this, but it doesn't have a mandate command language like SCPI, so which is not included in many instruments. That actually provides less bandwidth and lesser data flow, which is a disadvantage. So we would like to wrap it up here, and thank you so much. Thank you so much.
Thank you, sir.
Thank you.